Here's our agenda for today. First up, web evolution and basics. Then, internet protocols and infrastructure. Third, browser architecture and rendering. From there, we hit HTML5 structure and elements, followed by CSS styling and layouts, and finally, DevTools and project structure. Let's go.
All right, section 1, web evolution and basics. You know, people mix these two up all the time, but the internet and the web are distinctly different things. The internet? That's the physical routing infrastructure. It's the global network of connected computers. But the World Wide Web, which was invented years later, is just one service running on that infrastructure. It's exactly that, a collection of interconnected web pages and resources that we access through browsers. So the internet is the physical network, and the web is the service using it.
And this brilliantly illustrates how that web service has evolved over time. Web 1.0 was our first generation. Totally static web pages, read-only content, and zero user interaction. Fast and simple, sure, but highly limited. Then Web 2.0 comes along and gives us dynamic websites, user-generated content, and social platforms like YouTube and Facebook. It fundamentally allowed for real-time interactive communication. Now we're shifting toward Web 3.0. We're talking semantic, intelligent systems, AI, blockchain tech, and decentralized apps. Why does this actually matter? Because it provides direct data ownership and enhanced privacy. It's giving control back to the users.
Moving right along to Section 2, Internet Protocols and Infrastructure.
The absolute foundation of all this connectivity is the client-server architecture. It's a direct, continuous transaction. Your device, whether that's a web browser or a mobile app, which we call the client, sends a request. Then, a centralized computer or software, the server, processes that exact request and fires the requested data right back to you. This setup allows for centralized management and incredibly fast, efficient communication.
Now, to actually route those requests, we rely on three core components. First, the IP address. This is the unique numerical identifier assigned to every single connected device, using either IPv4 or IPv6 protocols. Second is DNS, or the domain name system. DNS is what converts memorable domain names, like google.com, into those numerical IP addresses so we can connect faster. And third, hosting. This is the literal process of storing website files on web servers, whether that's shared, VPS, or cloud environments, ensuring clients can reliably access those files online.
So, what's the actual difference between HTTP and HTTPS when transferring all those files? Well, HTTP is a stateless protocol for basic web communication. It operates on port 80, and crucially, it is completely unencrypted. Not secure at all. HTTPS is the secure version that utilizes port 443 and applies SSL or TLS encryption. This is absolutely crucial because it guarantees data privacy and secure transfers between the client and the server, keeping sensitive user information totally locked down.
Let's methodically break down the anatomy of one of these HTTP requests. First up, the methods. Get retrieves data, post sends data, put updates data, and delete removes it. Simple enough, right? Then, when the server actually replies, it uses status codes. 200 means success, 404 means page not found, and 500 indicates an internal server error. To direct these specific methods, we use a very strict URL structure. You've got the protocol, the domain, the specific path, and the query parameters.
Okay, let's zoom in a bit for Section 3, Browser Architecture and Rendering.
Your browser operates using several distinct components that have to work perfectly together. You have the user interface, which handles the address bar and the buttons you click every day. Then, the networking component handles those HTTP requests we just talked about. Storage manages your cookies, cache, and local storage to speed up future visits. The JavaScript engine executes the code that makes the page interactive. And finally, the rendering engine, like Blink for Chrome or Gecko for Firefox. This right here is the absolute heart of the visual experience. It actively converts raw code into the web page you actually see.
So the crucial point is how this exact engine operates. This entire 6-step rendering pipeline happens in a matter of milliseconds. First, the browser loads the HTML. Second, that HTML is converted into the document object model, or the DOM. Third, the CSS is converted into the CSS OM. Fourth, the DOM and the CSS OM are combined to create the render tree. Fifth, the browser performs a precise layout calculation based on that tree to determine exact geometric positions. And sixth, it paints the actual pixels right onto your screen.
That brings us to Section 4, HTML5 Structure and Elements. We use HTML, or Hypertext Markup Language, to build the actual structure of a web page, and it has come a really long way. Older HTML versions had very limited multimedia support, But HTML5 completely transformed things. It brought in built-in semantic elements, native APIs for audio and video, and significantly better form handling natively right inside the browser.
HTML uses very specific tags for its structure. Headings establish text titles and a strict hierarchy. Lists organize items into ordered or unordered formats. Tables are used to manage tabular data strictly using TR for rows, TD for data cells, and TH for headers. Media tags are what you use to directly embed images, audio, and video elements. And link tags seamlessly connect users to other resources across the web.
Now, forms are absolutely essential for collecting user input. We use input, text area, select, and button tags for this. And HTML5 added client-side form validation attributes, things like required, email, and min length. This makes sure the correct data is entered right away, resulting in a much smoother user experience. Plus, we have semantic tags like header, nav, section, and footer that provide explicit meaning to the document structure. Why does this matter? Well, semantic tags improve human readability, sure, but they are also absolutely crucial for search engine optimization. Now, what's really interesting about this slide is the strict geometric difference between block and inline elements. Block elements, like a div or a p tag, forcefully take up the full width of their parent container, and they always start on a new line. Inline elements, on the other hand, like a span or an a tag, only take up the exact width of their specific content. They do not force a new line, which allows text to flow naturally right around them.
All right, Section 5, CSS Styling and Layouts.
CSS is what visually transforms that raw HTML structure. Cascading style sheets provide better design, faster styling, and real code reusability. You can write CSS inline, internally, or externally. To actually apply these styles, CSS uses specific selectors to target HTML elements. A tag selector targets the element name directly. A class selector uses a period to target a defined class. And an ID selector uses a hash symbol to target a completely unique ID. Once you select it, basic properties like color or background color completely alter the visual state.
You have to know that every single HTML element is governed by the CSS box model. This is a critical structural concept with 4 distinct spatial dimensions. First, the content is the innermost area containing the actual text or image. Then, padding is the literal space inside the border, providing a bit of breathing room. The border is the visible boundary enclosing that padding and content. And finally, the margin is the literal space outside the border, actively pushing surrounding elements away.
To accurately arrange all those boxes, we use advanced layout systems. Flexbox is perfect for one-dimensional layouts, single rows or columns, using properties like justify content and align items for easy, responsive alignment. Grid handles the more complex two-dimensional constraints, organizing both rows and columns simultaneously. And for visual changes, transitions create smooth, linear changes between states, while animations allow for complex movement and visual effects by utilizing defined keyframes over time.
Last but not least, Section 6, DevTools and Project Structure. Let's zoom out slightly. A standard web project requires a logically organized folder structure. You typically have a root index.html file alongside separate subdirectories for CSS, JS, and images to ensure easy maintenance. To actually troubleshoot this architecture, modern browsers include built-in developer tools. The Inspect Element tab lets you view and temporarily tweak HTML and CSS on the fly. The Network tab is absolutely vital for monitoring HTTP requests and analyzing API load times. And the Console and Sources tabs are exactly where you'll be hunting down JavaScript errors and debugging your source files directly.
So we've broken down the entire web, from global IP protocols right down to local CSS pixels. But as we sprint toward the decentralized networks of Web 3.0, you really have to ask yourself, how will this fundamental client-server rendering pipeline adapt? Will our current browser rendering engines handle AI and blockchain integration seamlessly? Or are we going to need a completely new architecture entirely? It's a massive technical frontier. Thanks for joining us to explore it in this explainer.